All right, today we're going to dig into what it really takes to build a professional Python API. We're going to start with a super simple project and completely transform it into a strategic blueprint, one that's truly ready for massive scale, real-world problems, and yeah, even the future of AI.
So, what's the big difference, right? What separates a quick and dirty project from something that's genuinely production ready? Well, it's not just about writing code that works. The real trick is building an architecture that can last, something that's tough, easy to test, and can actually evolve without shattering into a million pieces. Think of it as the difference between a doodle on a napkin and a full-blown architectural blueprint.
You know, every great project has to start somewhere, usually with a first draft, and that's where we'll begin. We've got a simple, functional API for keeping track of heroes, and it's all built inside one single Python file. To get this off the ground, we're using the really powerful combination of FastAPI as our web framework and SQL model to talk to our database.
Now, the real magic ingredient in this first version is SQL model. It's awesome. With it, we can define our hero in a single Python class, and this one class becomes our single source of truth for literally everything. The shape of the data in our API, the validation rules, even the database table structure itself. It's just incredibly efficient.
Okay, but right away we run into a classic problem. The code to create a database connection, what we call a session, is just copied and pasted inside every single API function. Yeah, it works, but let's be honest, it's messy, it's repetitive, and it's going to be a total nightmare to test. This is pretty much the textbook definition of a first draft project.
So now it's time to level up. We're going to evolve our little script. And this is the point where we have to shift our thinking. Stop thinking like we're just writing a script and start thinking like a software architect. We're going to apply some professional patterns to make this API robust, clear, and way easier to test.
Our first big move is to use a pattern called dependency injection. Now, don't let the name scare you. Think of it like this. Instead of every part of our code trying to build its own tools from scratch, we have a central toolbox. We'll create the database session once in a little helper function, and then FastAPI will automatically inject, or basically just hand, that session to any API function that needs it.
And wow, the difference is just night and day. On the left, you've got that repetitive mess, but on the right, our code is clean, it's centralized, we just ask for a database session, and bam, it's provided. This separates our API logic from the whole database setup, which is a huge win for clean code, and this is the important part for testing.
So the next thing we figure out is that a single one-size-fits-all model just isn't going to cut it for a pro-level API. We need to be really specific about the shape of our data for every different thing we do. So we create a base model with the fields they all share, and then we use inheritance to build out specialized models for creating a hero, for reading one, and for updating one. This gives us pinpoint control over exactly what data comes in and what goes out.
But, things don't always go right. What happens when a user requests a hero ID that just doesn't exist? A professional API doesn't just blow up. It communicates clearly. So we build in some solid error handling to return standard codes, like a 404 and not found. This makes our API predictable and honestly just way more reliable for anybody who uses it.
Okay, so what if we have thousands of heroes? We can't just send the entire database to the user in one giant request. That would totally crash the server. The solution is something called pagination. We basically let the client ask for data in pages. They tell us where to start and how many to grab, and our API smartly just slices up the database query. This protects our server while giving the user all the control.
All right, we've got the basics down. Now it's time to really scale up. We're going to take everything we've just learned and throw it at a much bigger challenge. Building a quiz API for a government program that's going to have hundreds of thousands of users. This is where our simple little hero example gets put to a real-world test.
And you can feel it, right? The stakes are immediately way higher. This isn't just a tutorial anymore. This is a real production system. All of a sudden, things like performance, security, and how we handle complex data, they're not optional anymore. They are absolutely essential from the very first line of code.
At the very heart of this quiz app is the question bank. And trust me, this isn't just a simple list. It's a whole complex universe of topics and subtopics and all these different types of questions. Getting the data model right for this is absolutely key.
So how do we handle all that complexity? Well, we use that same awesome pattern we used for our heroes, inheritance. We start with a generic base question, and then we extend it to create all these specialized types, from simple multiple choice questions all the way to these complex multi-part case studies.
This approach keeps our data model super flexible and really easy to add to in the future.
Now, with this many users, you absolutely have to think defensively. How do we stop people from cheating? How do we make sure everything's fair? The answers to those questions have to be baked right into the API's design. For instance, the API randomizes the question order for everyone. It never sends the correct answers to the user's browser, and it does all the answer checking on the server. These aren't just features you tack on at the end, they're fundamental architectural decisions.
This brings us to our final, and definitely most advanced step. We're going beyond just building an API for a user interface that exists today. We're actually going to architect a system that is ready for the AI of tomorrow.
And this brings up a really fascinating architectural puzzle. A web app needs to call an AI to, say, generate some new quiz questions. But a custom GPT, well, it is the AI. So how in the world do you design one single system that can serve both of them without creating a total mess?
You can see the conflict, right? A traditional API that tries to handle AI generation internally creates this weird paradox. If a custom GPT calls an API endpoint that itself then calls another AI, you get this inefficient, confusing loop, an AI calling an API that calls another AI. We need a much cleaner way to do this.
The solution is a layered approach. We start with what we'll call a simple API. Think of this as the pure foundational layer. It only does the basic database stuff: create, read, update, delete. It has absolutely zero AI logic in it. This is the perfect, clean layer that a custom GPT can talk to directly and safely. Then we build a second wrapper API right on top of that. This is the layer that our actual graphical user interface talks to. This wrapper is the one that has the power to call out to external AIs. So it can ask a generative AI to create 20 new questions, and once it gets them back, it just uses this simple API to save them to the database. It creates two distinct, clean layers for two very different kinds of users: humans and machines.
And that's our journey. We took a simple single-file script, and step by step, we evolved it into a really robust, layered architecture, one that's truly ready for massive scale and, even better, seamless AI integration. This timeline really shows the whole evolution. We went from something fragile to something functional, then from functional to genuinely production-ready, and finally from production-ready to actually being future-proof. Each step added a new layer of professional thinking, transforming a simple little project into a real enterprise-grade blueprint.
So this leaves us with one final question, and this one's for you. When you build your next project, are you just going to build it to work for today? Or are you going to architect it so it can evolve for tomorrow? Because planning for future needs, things like AI integration, that's not an afterthought anymore. It's the very core of modern, durable software architecture.